See some familiar faces trickling in. Welcome, everyone. Just a few minutes before we get started. So I'd ask if everyone could mute themselves, please, and potentially turn off the video if that works. Well, looks like it's about 3 o'clock, so we'd like to get started. And I'd said a few times, but if everyone could please mute their microphones and turn off their cameras, it would really help us for the presentation. We'll just let one more minute pass here, just in case we have any folks joining in. I'm going to start off with a little introduction presentation, and but then we're going to get to the important speakers, Rebecca and Matt. And as always, feel free, if you have any questions or comments, put it in the chat box. I'll be monitoring that. Like we have 37 participants so far. 1 past 3, I think. I'd like to get started. We'll have a few folks trickling in as we do our introductions, but we got a lot to cover today, so I just want to make sure we leave enough time at the end for ample Q&A. So I'm going to get started. Thank you, everyone, for attending today, our virtual farming symposium. This webinar was sponsored by the Water Resources Council. They helped to fund this initiative, and then it's sponsored by the Town of Geneva and Seneca Lake Pure Waters. We're co-hosting the event today, so I really appreciate all of the partners who've helped out. And what we're going to talk about today is the concept of paying farmers for ecosystem services. My name is Jacob Fox, and I'm a Town of Geneva Climate Smart Coordinator, so I work on all things sustainability in the Town of Geneva. Next slide, please. What am I talking about and why? There's a lot of words that go to this: carbon farming, payment for ecosystem services, carbon credits, tax credits. There's lots of things that have entered the mainstream in the last few years, but really the concept is paying farmers for improving their land and how that can help us in the long run improve our water quality, air quality, and many of the problems we have from an environmental standpoint. Farmers are really in a great position to solve. They're also the largest land stewards in most of our communities, especially in upstate New York, in the Finger Lakes region, and they really have the knowledge and ability to make changes. So, what this program, could be about all is empowering farmers, to make those changes. And it's not all in one box. We're going to hear from a few different speakers today that are talking about, sequestered soil carbon, but there's a lot more to this puzzle. There's protecting biodiversity, there's retaining water, there's a lot of things under the confines of soil health, and we don't want to put it too much in a box here, but there's many things that people are measuring and talking about measuring that really come down to the fact that different approach at looking at a farm's value. So, right now we look at farms as, what crops they can sell, but, what value do they have in our watershed? and and what is the extra value, the other positive externalities, as you might say. Next slide, please. So we've been talking about this in the town of Geneva for a few years now. We are a very agricultural community, so we have an active ag enhancement board, and we were able to fund some trials where we measured soil carbon on some land in the town of Geneva. And we just kind of took a sample size of a few of the various land uses, and you'll see there in the chart. We did those tests in 2019. And we weren't able to do any trials in 2020, but we're excited for 2021. We're going to be working up at the Bejo Seeds farm on Healy Road to do a few plots for carbon farming trials. We're going to do some cover crop applications as well as some trichoderma and compost applications. And within this work of the town, I've been engaging with our work with Tompkins County Cooperative Extension. They have a working group that's really talking about this. So I'll invite Graham Savio, who's on the event right now, to put his contact information in the chat box. And if anyone's interested in the work that we're doing on the regional level to advocate for this, please reach out to Graham or me to get involved with that group. So next slide, please. So these are just a few things that we're talking about when we talk about improving soil health. On the left here is practices. On the right is also practices, and in the middle is potential ecosystem services. So, these aren't an exhaustive list, but they're a list that we have compiled to just really help to show, a start about what we're talking about. Next slide, please. So the next steps, we're going to hear from Rebecca Carlson from Nori, and we're going to hear from Matt Sheffer from Hudson Carbon. They're folks who are actively working in this space, and I'm incredibly honored and excited to hear from them. We're going to follow up their conversations with a Q&A, and then we have available a $20 payment for farmers in the Seneca Lake watershed that fill out the survey. So please look in the chat box for a link to that survey. And in the event details, there's also a link to that survey. So make sure and fill that out, get that back to us, and so you can qualify for your $20 payment. If you're interested, again, contact us. We can connect you with the Tompkins County group. And, just as always, reach out to me with any more questions. So I'm really excited today to introduce Rebecca Carlson from Nori. She'll be speaking first. So go ahead, take it away.
Awesome. Thank you so much, Jacob. And thank you everybody for the opportunity to come talk with you guys. I've only been to the Finger Lakes region once and had a blast, and it's such an idyllic farming community. So it's a privilege to be able to speak with farmers from there. So I'm Rebecca Carlson. I am from Nori. I'm the agriculture supply lead. My background is working as an agronomist in central Nebraska, as well as working as a researcher at various institutions with agriculture. And so my role in Nori is just really helping farmers go through the process. But I'm first going to talk about who Nori is as a company. So next slide, please. All right, so who is Nori? So Nori is a small company. We're I think 15 people. We are a startup that was founded in 2017, and our whole goal is to build a carbon marketplace to play a role in reversing climate change. We're actually carbon tool agnostic, so as we grow, we don't want to be just focused on soil organic carbon, but other type means to the end, but that is where we're starting. Next slide. So what we do in this is that we issue these Nori carbon removal tons, or Nrts, as I'll talk about a million times probably from here on out, to those people who remove and retain carbon. And so for each Nrt, we have a Nori token that we issued, and it'll be retired from the blockchain. And so in this little graphic, we see what Nori is doing is actually taking solar or carbon that's taking out of the atmosphere and rewarding that. We're not working with reductions or avoidances, but only those that are taken out of the atmosphere and removed and retained in a reservoir. And we do this with the blockchain, which I'll talk about briefly, but it mainly is just put in place to avoid frauds, because in previous marketplaces, there was a lot of fraud of double counting. And so because we're working from a blockchain point of view, whatever is removed or whatever Nrt is retired, it's removed from the blockchain. It can never be double sold. So next slide, please. So what we're doing, Almost, thank you. Our first step in doing this carbon removal is building soil carbon with agricultural practices. So our first methodology is working with U.S. croplands and working with increasing our soil organic carbon with these regenerative practices. The tool we use right now is Soil Metrics, and Soil Metrics is kind of the commercial arm of Comet Farm. And they use a greenhouse gas emissions tool that meets the USDA Blue Book standards to run all these modelings based on your agronomic practices, weather in your area, and soil types in your area. So what we need from farmers is actually 30 years of farm data, which is a lot, but we have a lot of tools to help kind of like expedite this process because, I mean, honestly, we like hardly had the internet in 2002, let alone this wonderful, farm software management tools of like when you tilled. So we need farmers with different tools to help them with this process. Next slide. Maybe. Thank you. So the steps and how we actually do this and how we're like then working with farmers to get these NRTs registered and on our marketplace. Our first step is data collection. So we're entering in historic farm practices from 2000 through 2030, working with the farmers to get this kind of data. Then we go through verification. And so as we run the model with the data we put into the records, we then have to have a third-party verifier who comes in and verifies that these practices have taken place and that, again, to avoid fraud and verify the operations. Then the farmers go and sign an NRT agreement, which is a 10-year contract after the issuance of these NRTs. We issue the NRTs and then we go through and sell them. And I'll go through each of these steps further in the presentation. So next slide, please. What we do is like who qualifies. So it's not all farmers qualify for the Nori marketplace at this point. It's those who are in the US and have adopted regenerative practices since 2010. What this means is have you adopted like cover cropping in the past 10 years or 11 years, or adopted a manure addition? Because I know there's a lot of farmers who've done no-till, for example, for 30 years, but then, am I choppy, anyone? Sorry, I just got choppy. Okay, good to go, so I'll keep going on. So where was I? Oh yeah, so if a farmer was doing no-till for about 20 years, but then adopted, again, cover crops in 2015, that qualifies for the Nori marketplace. We need field boundaries from the farmer to then submit into the soil metrics model, and that's what pulls the soil data as well as the weather data. Again, the fields need to be US crop based, which is fine in Seneca area and the watershed. One thing that we don't allow is for land that has previously been in conservation reserve programs. So, land that has been in prairie or in native grasses and then gets switched out of that because that constitutes a land use change. And the numbers will be pretty poor after that. And then a farmer who's willing to pay the verification costs. So next slide, please.
Walking too fast.
Oh, sorry. I'll slow down. So again, how we do it with the farm records, what we need are the boundary files, the historic farm management data from 2000 to 2000 through the switch year. And we use tools called Smart Defaults, which actually pulls information from satellite imagery and matches it to crop dayscape layer to understand what the projects, what the rotations were on that field. We need these present records then, and the regenerative switch is kind of what defines the present records of, say you switched in 2016, we'll need information 3 years prior to that through the present of the verifiable records to show the verifiers that it was something else and then it changed. And then the hypothetical future operations are what build out the rest of the model. So you can see for over the course of a 10-year project, what is your Nori project worth? Next slide, please. So we need all of these pieces of information to build out how we issue NRTs. So what counts as an incremental ton of CO2, which it represents an NRT, is the difference between what you did in the past in those blue bars, the old practices, were still sequestering carbon. You're still putting plants on the ground. So we are sequestering a bit of carbon, but then say in this example, we switched in 2014 to a regenerative practice, we're sequestering more carbon than before. Next slide, please. So what we issue these NRTs on are the difference between that blue bar and the gold bar. And so because we need historic records to build out the blue to carry forward into the future, and then we need the future records to show over time, what is this difference between old and new practices? And we do this as incremental practices. So we're not actually, as you can see, kind of like in year 2022, even there's a drought year and you're going to be, you're going to be releasing carbon based on weather practices, still incrementally from what it was before, you're still getting issued NRTs. However, in contrast to this, say you did have a lot of incredible like restorative practices in your baseline, the difference then of what did happen and what's happening now will be small. And so that's what kind of drives lower NRT numbers for a project. Next slide, please. So after we have all of the information run, we put all the data in the model, we run the model, we understand, how many NRTs are issued. The next step is verification. I do want to actually pause and note that I'm talking a lot about farm data, and as Nori, we don't own any farm data. The only thing we use it for is to run the models, and all of that farm data lies exclusively in the hands of the farmer, or if they're using another farm software, that's fine. But Nori never has their hand in the pot of the data of their farmer because we really value and respect that is an asset for the farmer themselves. So once we have all that data in our platform, we have the verification. And so this verification step is a step that's paid for by the farmer. You have to pay for your seed to grow the plants. You have to pay for verification, as it again comes off as a bit fraud if we're saying, oh yes, it's a great project, it's in our marketplace. So who are verifiers? Well, they're Nori approved verifiers with agronomic experience. We're currently working with 3 companies, Esther Global, Validus, and SCS. And what they need are like reliable and replicable data, proof of property assignments, and this is important that the landowners are aware that this project is being enrolled in Nori. A primary contact assigned, somebody to verify what basically a touch point for the project, and they need evidence of this agronomic change. And so what tangibly this looks like is that they look at like field receipts, for example, for like seed receipts if it was a cover crop, or if you bought a no-till implementation. They also usually have like conversations with the farmers themselves to understand what took place on their land. And as of now, we have about the cost of this is about $2,500 to $5,000, depending on like the scale of the project, how big it is. And again, it's paid for by the supplier. Next slide, please. So then the next step is the contract for the NRT agreement. And the contract is in place because unlike other commodities, the value of carbon really comes with the time that's the carbon is in the soil. Like buyers are really looking for, impermanence. They want the carbon out of the atmosphere for 1,000 years. But we working with farmers, like we can't commit farmers to 1,000 years of data records or any of that. So we have a 10-year commitment, again, bound by meeting the farmers where they're at, bound by the science that we have access to, not access to, but like the organic carbon is a fairly young field of science, and so we want to operate with what we know. And so this 10-year commitment is put in place that you need to update the farm records each year and then verify it at least every 3 years. We have the ability, in the contract, you also have the ability to set your own price for the NRT, again, helping farmers understand what the value of what their carbon removal is. That's currently selling at $50 per NRT, but we expect that to change over time. There's a commitment within the contract to sell at least 15% of your NRTs on the Nori marketplace. As other marketplaces develop and you think you could get a better price on another platform, you can retire 85% of your NRTs and sell them on another platform. But we do ask for 15% to be not ask, you must have 15% on the Nori marketplace, because we make, the way that Nori operates is we make money off of the sale of the NRT, and we take that from the buyer, not from the farmer. And then the main purpose behind it all is that this carbon that's sequestered remains in the ground for the duration of the contract. We do have clauses for events due to weather, because we know that farming is very unpredictable, so we don't want to hold a farmer accountable to something that the weather would kind of trash anyways. So next slide, please. So after we have the verification in place, the NRT contract signed, then we issue our NRTs. And once these NRTs are issued, they go directly onto the marketplace at the price that you sell, and we can go ahead and then sell our NRTs. So next slide, please. What this looks like right now, is that we have many types of buyers, much like we're working with many types of farmers. We want to have a carbon removal marketplace accessible to as many buyers as possible as well. Previously, in other carbon marketplaces, there would be brokers, which would drive the price incredibly high. But because we have a lower price, individuals can go onto our website and buy Nori removal tons to offset, say, their like plane emissions or just like offset their carbon footprint. We work with small, medium businesses as well as corporate buyers to purchase the Nrts. Next slide, please. And this is not like the prettiest of slides, but the way in which we are selling them, right now we have two means of selling Nrts. Again, this first in, first out queue. Just like as somebody enters the Nori marketplace, those get sold first, and then the next supplier in line, and so on and so forth. We also have business, like B2B or business sales. So our business sells to another business, and they're usually larger volumes of purchases. We had the sale to Shopify back in November, and they bought 5,000 Nrts to offset their Black Friday emissions costs, and other deals similar to that. In the future, though, like again, as we're building this marketplace, we're not only helping the buyers, but helping the suppliers. Moving forward in 2021, we're working on the forward contract auction, which will have like large scale, long-term contracts with buyers that want to buy, X amount of Nrts like every month, as well as an API integration. So next time you're on Amazon, for example, not necessarily, but if you want to offset the carbon emissions, it would be integrated right into our API. So next slide, please. So as I've been talking with farmers from all over and different companies are like, well, how do you market to farmers? Like, what's the best way that you reach the farmer at the farm gate? And as a former agronomist, it's just like, you got to show people like the farmers what works, right? So we've actually paid 2 farmers so far. Again, doesn't seem like much, but we're a pretty young company. So it's been a feat, and we're really proud of the farmers we've paid so far. Trey Hill, who's in Maryland, and Kelly Garrett, who's in Iowa. And so we're just like constantly, our main goal is to show people things that work. I'm not one to be fancy, just one to show somebody the working product. And in this process, like it's not an easy process, right? When you think of 30 years of data, it's just like, oh, what a headache. But because of that, because we're constantly working with the farmers and getting feedback, we've simplified the data entry process, again, to meet farmers where they're at. Next slide, please. But with all that, we are in the Nori pilot, and we're learning a lot. Like this is the Wild West. I mean, the excitement around carbon marketplaces and payment for ecosystem services is just like such a hype. And there's like a lot of tall tales out there of how much we can get paid, where we should go, how much we deserve. And it's really tough to navigate. So as Nori, we're just trying to get it right and not to be right. We've taken some wrong turns in the past and made false promises, but we really want to get back on track and again, show people things that work and doing it in the right way. And with that, we really value the input of the people we're working with. We're building the marketplace. Again, I'm constantly talking with farmers or companies that are working with us of like how to make it easier. How do we help the farmer, but also be scientifically appropriate and accurate, as well as meeting the buyers where they're at. And my word, it is complicated. Farm data is such a valuable asset, but it's not always easy to access, and getting this into a simplified process that's streamlined, takes some gumption, but we're here for it. So we're constantly learning, constantly improving, but always helping to bring value back to the farmer for being a good steward of their land. And the next slide. All right, thank you. That's about it. If you have any questions, I mean, obviously we'll answer questions beforehand, but thank you for listening to a quick little overview of how Nori's situating themselves in the carbon marketplace.
Thanks so much, Rebecca. Really incredible stuff. I've been following y'all for a few years now, and it's really just great to see the strides that you've made. I have a few questions here that I feel like we could answer real quick before we start Matt's presentation. So, and if you see in the chat, are you primarily focused on farms that grow annual crops, vegetables, field crops, forage, etc.?
Not necessarily. We're working with a couple perennial crops. With the soil metrics modeling, we're kind of bound, you're only as good as the tools you use. And some of the other perennials are not as robust of tools within the process, but they do have good crop models for, different perennials like grape, like in vineyards or alfalfa and those kind of things. But with our small data set of farmers we're working with so far, I mean, we have many more we're working with, but the main focus has been these larger annual crops.
The next question, does your program actually reduce the amount of carbon released by business or just pay farmers to sequester it? And are you doing business in New York?
Yeah, so ours is, so we're not working with reductions of carbon, we're working with the offset of it. So in a way, it's like if as a, I don't know, as a factor in the equation of reversing climate change, we do need to pull out the carbon out in the atmosphere. And so businesses, as a part of their like suite of sustainability goals, one of them could be the reduction or the removal of carbon through the offsetting through a program such as Nori, as long with other reducing of their own emissions as well. But we are just helping farmers get paid from businesses who are offsetting their carbon emissions.
And that dovetails, yeah.
Yes, we are working with a couple farms in New York. And everybody can buy, anybody, even internationally, can purchase NRTs.
Yeah, that's the last question for you is why did they buy NRTs? What did they do with them?
Yes, that is a great question. It's such a it's a digital asset, right? You're offsetting your emissions. So we can make calculations of, say, their business did X amount of shipping and that emits X amount of carbon. And so to neutralize that, they buy say they emit 100 tons of carbon, they'll buy 100 tons of carbon. And so knowing like through the scientific modeling that we're doing, that carbon is actually removed and restored. And so over time, we're going to reach that equilibrium. So they use it for their sustainability goals at this point. And I'm not on the sales side, I'm on the farming side, but I can also direct questions like that to the people on our sales team.
Thanks so much. That's all. If the owner didn't own the farm until 2007, how can he participate?
Oh, totally. So many questions. So they can definitely participate. So because we use satellite imagery to help understand what the previous practices were, we can backfill the information with like the rule of thumb estimates of what the practices were. And then if they switch to regenerative practice in 2012, you'll have like pretty robust data for that. I'm just gonna go to, can NRTs be resold? They cannot be resold. You can retire it on behalf of somebody else, but because we want to not have double counting, you can only have one sale. One NRT can only be sold once.
The last one, to discuss issues around size, acreage, are you interested in developing models to work with smaller farms? I think we touched on that at the beginning, but if you want to elaborate.
Yeah, absolutely. Because of that portion of like the verification cost, we never want to have a farmer put in work and then have the verification be more than what the value of the NRTs are worth. I mean, we're working with verifiers, and the more that we have go through, the price will go down. So we do work with people who aggregate smaller farms and then have it submitted to verification as one project. Because I mean, one of my like ultimate goals is to work with all types of farmers with all sizes. And that's one of the ways that we can access that we're not putting an unjust burden on the farmer itself.
And the last one, many inputs are used on farms involve release of large amounts of carbon. Do you do a life cycle analysis to ensure that not more carbon is released by a farm than the amount sequestered?
So we do not do an LCA right now. We do the fact that we're doing the incremental so organic carbon stock changes, it kind of comes out in the baseline of what you used to do and what's above. So the carbon releases and fluxes that happen are going to be carried through over time and kind of minimize that with the denominator. But we are also asking for like our energy use of the farm itself. Again, with the tools we're using, and this will get more robust with time, but in our pilot phase, trying to get it right and not be right, we're focusing small and soil organic carbon. And therefore gathering more data to understand the full breadth of it, because like our other greenhouse gases of nitrous oxide emissions, methane gas, and all that, the uncertainty is so large with them that it's hard to make appropriate claims of what's actually happening on the field scale. And we do rented property as well.
Well, great. And so we're coming up on half hour, so I'd like to, or I see Caitlin put in there a little reminder about the survey. So make sure and get over, fill that survey out, or at least pull up the link. So at the end of it, and I'd like to introduce our next speaker, Matt Sheffer. Matt's been doing some work in the Hudson Valley, and I really was excited I've been, kind of following them from afar, but, they're in New York State. And so I'm excited that they're operating in our climate. And so, I'd like Matt, take it away and let us know, what y'all are doing there at Hudson Carbon.
Great. Thank you, Jacob. Thank you, Rebecca. It's a pleasure to be here with all of you. My name is Matt Sheffer. I am the Managing Director of Hudson Carbon. A little bit about myself. I come primarily from an agricultural background. I have over 10 years experience in production ag and specialty crops, grains, and livestock, and also sort of informal background through independent study of production ecology, soil science, and ecological economics. And I'm here today to talk about our research institute, Hudson Carbon. I'm going to touch on things that both Jacob and Rebecca have talked about already, and also kind of getting a little bit more into the weeds on the quantification side that Rebecca touched on, but also talking on a sort of higher level of about carbon markets and ecosystem service markets in general. So next slide, please. So our mission at Hudson Carbon is that we are dedicated to catalyzing the adoption of regenerative organic agriculture through advancing on-farm research, improving measurement tools, and developing better project methodologies to provide greater access to new revenue streams for farmers through ecosystem services. To put it in a sentence, farmers need to get paid for not only what they grow, but how they grow it. Next slide, please. So to set the context, I want to just touch on how we are thinking about regenerative organic management systems. Depending on who you ask and what context you're in, there's many definitions. Because of the research that we're doing at our primary research farm, Stonehouse Farm in the Hudson Valley, we've sort of developed a holistic definition of a regenerative organic production system. And I just wanted to touch on some of those details to set the context of our research. So next slide, please. So to touch on the principles, they all sort of kind of center around biodiversity in the crop rotation and the production system in the layered enterprises. And then sort of around that, what a regenerative organic system strives to achieve is tillage reduction, maximize soil cover, improve nutrient cycling, the integration of animals, water use efficiency, and protecting adjacent ecosystems and waterways, and minimizing synthetic inputs. Next slide, please. So in order to achieve those goals, the sort of centerpiece for Stonehouse Farm in particular is a full crop rotation. And by that, I mean an annual rotation that integrates a perennial phase of grasses and legumes for grazing and forage to serve as a sort of rest and reset phase that restores soil carbon, improves nutrient cycling, drives carbon sequestration into deeper layers of the soil. I'll get into that a little bit more. And then around that full crop rotation, layering on different cover cropping techniques during the annual phase, practicing organic no-till, which is tricky in our climate, but can be implemented in other other regions across the US and the globe, composting, planned grazing, and then incorporating woody perennials and agroforestry, silvopasture, alley cropping, and using natural fertility inputs, and then again, protecting adjacent ecosystems with riparian buffers. Next slide, please. And then what you get through the practice of these systems, the benefits, if you will, are nutrient-dense food, greenhouse gas emissions reductions, of course, carbon sequestration, but also on the economic side, reduced off-farm inputs, sort of resiliency on the two extremes of flood and drought, a diversity in your production system that can support more local and regional economies, improved water quality, and of course, reduced pollution in the form of the eutrophication of waterways and also farm chemical runoff. Next slide, please. And here, I just wanted to give some visual examples of what these practices look like in the context of Stonehouse Farm. So below is a rough example of the annual phase, the 3-year annual phase of the full rotation. Stonehouse Farm comes out of perennial sod with a moldboard plowing and plants corn, and then plants a cover crop at the end of the season, and then moves into either soybeans, sunflowers, field peas, or buckwheat. In this example, you see sunflowers. And then after that, or oilseed or pulse crop, they move into a cereal grain crop, which is then the unique opportunity to seed down via the practice of interseeding or companion planting perennials. And you can see an example of that in the upper left corner here, where you have a winter wheat crop that was undersown with medium red clover and orchard grass. This happened in the early spring as the cereal grain was coming out of dormancy. There was a fertilizer blend that was mixed with grass and clover seed that was frost seeded on in early spring. And the cereal grain year offers, again, that unique opportunity to seed down and avoid tillage and to move into that perennial phase. And then moving to the right here, the next picture is an example of a Rye Veg Cover Crop that you would typically see at Stonehouse following a corn planting that is then rolled and crimped for no-till soybeans. The next is a chestnut sapling in a perennial hayfield that has been planted in an alley to set up an alley cropping system. The next is some beef cattle being managed with single strand poly wire. And then picture of a compost windrow, static windrow that's been seeded down to kind of maximize the fungal to bacterial ratio of the compost. Next slide, please. So the kind of research that Hudson Carbon is engaged in is systems-based research. We focus on gathering data within working farm systems. We don't kind of break fields up into replicated plots and isolate variables. We like to see, we like to look at different metrics within a whole system as it is being practiced in real life and in real time. So that's the approach that we take at Stonehouse Farm and the other farms that we conduct research at in the Northeast. Next slide, please. And so what's driving our work here is essentially to advance research to benefit farmers within ecosystem service markets. And one of our primary focuses is advancing the study of deep soil carbon. A lot of research to date and a lot of soil health assessment tools and soil sampling protocols make recommendations for sampling to specific depths, mostly 20 to 30 centimeters. But when you're incorporating not only perennial forage, but also woody perennials, trees, et cetera, you're obviously going to be driving root growth beyond 30 centimeters. And it's in that rhizosphere where all the magic is happening, where nutrient cycling is happening, and where carbon is being stabilized through those processes. So when you're measuring, basically essentially we do soil sampling down to a meter, and that represents 5 times more soil than what is typically measured in these protocols, as well as in process-based models. So in the context of ecosystem service markets, you're leaving a lot of carbon on the table, so to speak, and sacrificing a lot of value. So we're dedicated to really advancing study of those dynamics in deep soil carbon and working to integrate that into quantification tools that carbon markets and registries utilize. And then furthermore, looking at the complexities of greenhouse gas fluxes in cropping and livestock systems, to better understand how whole management systems influence those fluxes, especially of methane and nitrous oxide, as they are much more potent than carbon dioxide. And these have implications for the appropriate scale of livestock operations and manure management practices. And then finally, looking at how soil carbon provides the foundation for an improved water cycle and also for biodiversity, for the purposes of increasing the value of payments for ecosystem services, so that you're not just focusing on carbon drawdown, but other value that carbon is sort of setting the stage for. So next slide, please. I'm just gonna zip through. Can everybody hear me? Is there?
Yes, we can hear you.
Okay, yeah, next slide, please. Okay, great, cool. Just making sure. Yeah, if I get choppy or cut out, just yell at me. So I wanna sort of zip through the data points that we're gathering. We focus on gathering data at key points within the carbon cycle, starting with biomass. Monthly above ground plant biomass sampling can track fluctuations in plant growth, residue cover, and in certain contexts, forage utilization. Next slide, please. Again, deep soil carbon that we extract cores down to a meter with a hydraulic soil coring machine, and then stratify that sample to specific horizon layers so that we can pinpoint exactly where we're seeing the most sort of dynamism, most incremental gains in soil carbon. We have a lab on site that we worked with scenic Hudson to build, where we do soil texture analysis, aggregate stability analysis, as well as carbon analysis using loss on ignition and dry combustion. Next slide, please. We also do some complex greenhouse gas flux monitoring using a couple different methods. The first is using the static chamber, where you have a portable analyzer hooked up to a clear chamber that can measure the concentrations of CO2 and methane over time, and that can capture sort of spatial variability. You deploy this method at various points throughout the field. And the idea here is you can throw a blackout curtain over the top of the chamber and sort of arrest the photosynthetic process and to measure that soil respiration. And then you can get what's called net ecosystem exchange, which tells you at any given point throughout the growing season whether the system in that field is a net source or sink of CO2. Next slide, please. And so layered on top of that is another method of greenhouse gas flux analysis called the eddy covariance method, where you use these fancy sensors that you see to the left here. And the first is a carbon dioxide spectrophotometer. It's a mouthful. It's basically an open path CO2 analyzer. The next instrument to the right of it is called a sonic anemometer, and essentially what it does is measures the three-dimensional wind turbulence and then correlates that to concentrations of carbon dioxide, making the assumption that upward fluxes of CO2 are emissions and downward fluxes are sinks. And that can give you a picture of CO2 fluctuations at field scale over time. So pairing those two methods together can give you a good picture of how CO2 is moving through above ground biomass at any given point throughout the growing season. Next slide, please. And we've recently gotten into measuring quantity and quality parameters in our adjacent streams and drainage swales using different techniques, focusing on volume and flow volume and velocity, as well as specific quality parameters like dissolved oxygen, dissolved organic matter, pH and temperature, and then nitrate and ammonium. And this gives us a picture not only the level of eutrophication or nutrient pollution that is coming off the fields at Stonehouse into the waterways, but also how much carbon we might be losing to what's called lateral carbon loss, just a fancy word for erosion. So next slide, please. And just wanted to highlight some key findings from Stonehouse Farms to give you a sense of what we're seeing. We've been measuring carbon, soil carbon, at 10 different sites across the farm, representing many different soil types, ranging from heavy clays to gravelly, sandy loam. And the top two sites, C site 4, is a what's called a Huzik gravelly silt loam, and that was in an annual rotation and then seeded down. And these graphs to the left here represent 4 years of data, and it was seeded down in the 4th year after spring barley to alfalfa. And then below it is C site 6, and that has been perennials in hay since the beginning of the study. But I want to also draw your attention to the two graphs to the right, which is a breakdown based on horizon layer that I was talking about before. And if you note the C5, the light blue. Those slopes are the steepest out of all horizon layers, which is exciting for us because it's indicating that, even though it's a smaller volume of, or it's a smaller mass of carbon compared to the upper layers, it is representing the highest incremental increase throughout that soil profile over time, indicating that the bottom 40 centimeters, that 60 to 100 centimeters has a lot of potential to store carbon over time. Next slide, please. And a little more data from Stonehouse Farm. We've created a farm-wide regression model and calculated tons of CO2 equivalent sequestered since the beginning of the farm's transition in 2015. And we've calculated a rate of about 3.22 tons of CO2 equivalent per acre per year when using the 95% confidence interval statistical analysis. But also want to draw your attention to the bottom right graph, which is a conventional farm that we monitor down the road, which practices conventional tillage without cover crops and strictly synthetic fertility inputs. You kind of see a little bit of a bell curve, but the average sort of regression slope over time is indicating a loss of carbon compared to the regenerative organic system that Stonehouse is practicing. Next slide, please. So what do we do with this data? Well, we're dedicated to using our research not just to sort of contribute to the canon of literature. We want to put it to work. We want it to provide a foundation for payments for ecosystem services and supporting access for farmers. And the way we do this is participating in projects that develop remote sensing tools, process-based modeling, and adaptive sampling. And I'll explain these three sort of buckets in the next slides. So next slide, please. Carbon markets to date mostly rely on process-based modeling to quantify fluxes of greenhouse gases within agricultural systems. These models are very sophisticated, but the use case for models is a context where there isn't a robust soil data set to make measurements. So what they do is they take farm management data, so sort of basic information about the management system, what it's growing, and where the farm is located to infer kind of local meteorological data, and then into the specifics of the management system, including tillage, types of crops that are grown, how and when they're planted, the nutrient management protocols, and also harvest information. And those inputs are run through a computer simulation to calculate how much carbon is being sequestered in the soil, how much methane and CO2, or how much methane and nitrous oxide are being emitted, et cetera. Working with partners on using our data to improve these models, because these models are only as good as the ground truth data that is used to calibrate them. Currently, there's not a lot of data that has gone into tuning the DayCent model and DNDC from the Northeast. DayCent is what is used in the background of the Comet, the USDA's Comet Farm tool that To my knowledge, that tool has been calibrated mostly with data from the Midwest and the Great Plains in annual cropping systems, as well as some grazing, and through a process in which we use Stonehouse Farms data and run it through that model. The differences between what we were seeing in our data and what the model was telling us were pretty drastic. So it's sort of highlighting this issue for us that, you know, a big effort needs to be undertaken to, you know, make these process-based models more bioregionally applicable, not only in terms of, you know, geography and climate, but also in terms of the complexity of systems, and also just very simply how much soil they measure and how sophisticated they are in capturing benefits of a synergistic management system. Next slide, please. The remote sensing piece is sort of tagged on to the modeling piece in that it allows, when models work well, it allows for the sort of automation of the modeling process by being able to identify what practices are happening on the ground, and also which crops are being planted. So, you know, how often the farm's tilling, when the crops were harvested, what crops have, you know, were planted, what the sort of overall rotation looks like. All these remote sensing tools can greatly improve the efficiency of the modeling process and cut costs for project registration and verification. And we're working as the agricultural lead on a project called Climate Trace to develop these kinds of models, as well as working with other partners to improve their versions of this kind of remote sensing tool. Next slide, please. And so where models don't perform, we feel that it's important to have a direct measurement protocol that it can capture what's happening on the ground. And we call this adaptive sampling, which essentially means using specific variables that you can measure in field, in situ, to capture spatial variability at field and farm scale, to then decrease the amount of soil sampling that you have to do to make it economically feasible, while maintaining an acceptable level of accuracy. So we work with tools built by by Veris Technologies that are actually fairly widely in use for the purposes of, you know, doing better variable rate application and variable rate planting, to, you know, use the same variables to measure and quantify spatial variability, so that you're not having to sample soil every half acre or every quarter acre in order to get an accurate, you know, an accurate reading of soil carbon stock change over time. So we feel that this quantification approach is important to develop alongside the process-based modeling approach to sort of fill in where models don't perform, to maintain access for farmers to carbon markets, and to actually, you know, capture the full value and the full benefit that farmers are producing in their management systems. Next slide, please. And then this is, there's surface variability that you can map out, and we also use sensors that capture variability at depth to kind of work with our soil sampling protocols that intend to quantify benefit down to 100 centimeters at least. Next slide, please. And so based on the research that we've done and our experience in, working with carbon registries, we're starting to think and in some sense rethink how carbon markets address agricultural projects. And we've been working for about a year now on our own, what we're calling the Hudson Carbon Exchange, that is sort of a response to the sort of the state of play within carbon markets for agriculture. Next slide, please. So I'm just going to touch on this at a high level because our marketplace is not quite as developed yet as Nori's, but just wanted to capture some high level kind of motivations for why we're getting into this space. It's our opinion that existing markets fail to fully benefit farmers and to achieve net impact. To date, markets have failed to command an actual actionable price for offsets. The price for offsets has, to date, generally been driven by polluters, by those required to purchase them, and therefore these prices are self-serving on that side of the equation and don't equate to any meaningful sort of addition to a farmer's bottom line that would influence them to make any significant systems level changes that would actually make these revenue streams work for farmers. And beyond that, markets have also failed to adequately quantify and monetize the co-benefits that naturally accrue upon that solid foundation of soil organic carbon. So again, the water piece and the biodiversity piece that are so utterly essential to quantify and monetize, because when sort of singularly looking at carbon, you can't, it's essentially important to fold all those in to actually command the value necessary to catalyze that change across the landscape. Also, eligibility requirements are poorly defined and don't sort of represent the real world, like supply and demand leakage within a global commodity market that's oversupplied, for example. Existing registry methodologies attempt to universally employ quantification tools that are limited in scope. Again, the modeling issue and its bioregional applicability that ultimately results in undercounting and undervaluing the impact of regenerative organic agricultural systems. And then finally, the market lacks the appropriate financial instruments to support the upfront costs of transitioning. Transitioning the farm to a different system is a huge undertaking, and it often takes a lot of upfront investment. However, markets currently only monetize impact that's already occurred, and therefore a farmer needs to figure out how to finance this kind of transition up front. And there's a lot of organizations that are trying to figure this out and trying to crack this nut, but we believe that it should be a part of the market itself, much like a commodities future contract, where future benefit is estimated and monetized and can go towards financing a transition, and then the actual impact is trued up over time. So those are sort of high level points and how we're thinking about markets at this point. Next slide, please. So our vision is to build a an exchange that addresses all those points, and that benefits farmers first. Farmers need to be capturing most of the value from the work that they're doing on the land, and they are the engines of change. So it's important to keep that in mind. Next slide, please. And so not only, hitting the points that I just made around carbon price and the bioregional applicability of models, financial instruments, and appropriate quantification tools, but also looking at a farm's supply chain, for instance, and the sort of upstream and downstream impacts of the whole system. I mean, you can isolate a farm and look at its practices and assess what the benefit is in terms of soil carbon within a very narrow context. But if you're talking about farms that are participating in a global commodity market, and say you're a farm in Brazil that is practicing no-till soybean and corn growing, but this is happening in the wake of Amazon deforestation, and commodities are going to confined animal feeding operations that are emitting nitrous oxide and methane, then you have to take those upstream and downstream impacts into consideration, and therefore the need to sort of rethink the global commodity system and how that fits within carbon markets is essential. And for us, the solution is you have to get more regional, and you have to clean up those supply chains, and make sure food is coming from and going into clean supply chains. And also the idea of adding additional value for co-benefits and improving eligibility requirements. Next slide, please. So the kind of exchange or marketplace that we're thinking of is one that is, that doesn't, that differentiates projects and doesn't treat these credits as commodities, but that treats them as unique place-based sort of almost tangible assets, and one that connects buyers like brands that are interested in cleaning up their supply chain or meeting professed goals of offsetting impact, as well as other entities. So connecting them directly to specific projects that they might care about is a way in which you can really highlight projects and connect people to place and actually command a higher price for your environmental impact, for the ecosystem services that you're providing. In the same way that if you start growing a grain or other food product for a local market that commands a premium, if you kind of localize and de-commodify these impacts, then it's a way that you can extract more value. Next slide, please. And just a little bit of math based on what we're seeing in our data, as well as sort of pricing model that we've thought through. A credit that not only takes carbon but other ecosystem services into account, that's priced at $100 per ton, and on a farm where you're seeing anywhere between 1 and 4 tons of CO2 equivalent per acre per year, that means an additional $50 to $400 per acre per year. And at that high end, I mean, that's motivating for farms to make a change. And if you can unlock that, a portion of that value up front to support transition, then you're off to the races. Next slide, please. So just a bit about how we're seeing this sort of market concept sort of producing impact. Of course, unlocking new revenue streams for farmers and promoting ecologically viable agricultural systems. You know, agriculture does exist on what I sort of call a externality spectrum, where, you know, it is capable, based on your management style, of producing a lot of negative externalities, but with management tweaks, you can kind of move along that continuum and be a net provider of positive externalities, for lack of a better word. But you know, the whole point of what we're talking about here today is internalizing those externalities and placing value on them. And also the supply chain issue, and you can, through a system that, you know, pays attention to supply chains and actually is sort of linked to organizations that, you know, are dedicated to building better regional supply chains to support farmers. You know, this market can play a big role in helping build out the whole food system. And it, of course, can, you know, play a role in reviving rural economies, keeping farmers on the land, making sure they're making a living, and ultimately can reconnect farmers to their surrounding communities by plugging them into these local and regional supply chains. So next slide, please. That's about it for me. This is just a bit about our partners and myself and who we are, my colleague Ben Dobson. Yeah, that's it. Thank you for your time and attention, and look forward to answering questions.
Thanks so much. Really incredible presentation. And so it looks like we got a few questions here. We had a few come in actually at the end of Rebecca's talk. So maybe we could get you to answer those real quick. One question, is it $15 NRT per acre was the question.
So right now, NRTs are selling for $15 per NRT, but the farmer sets the price of their NRT. And all of the projects we've run, we're only seeing about 0.45 NRTs per acre at this point. We're really issuing conservatively on the front side of things. So that's where we're at.
So the next question, you said you pay in tokens, parentheses, cryptocurrency. How do farmers convert this to money to take to the bank?
Yes. In the pilot phase, we're paying in cash. We're launching the token later this year, and you can trade it for cash immediately when you're issued it, when we're out of the pilot phase, or you can hold on to it to see how the price changes.
I think this is for Matt. What tests are you using to measure soil carbon? Do you identify the different types of carbon in the pool?
So we've used lost on ignition, as well as dry combustion, using an elemental analyzer. Lost on ignition is your typical test to measure organic matter, and then you apply a standard conversion factor to estimate that carbon content. However, in our research, and as we apply that method alongside dry combustion in those deeper soil layers, we're finding that loss on ignition using that standard conversion factor doesn't perform as well because of the structural differences in both density at that depth. We're finding that, you know, we're essentially kind of creating, based on soil texture, different conversion factors for loss on ignition at those depths, and finding that, you know, dry combustion is a more accurate approach to measuring carbon at those depths. As far as carbon pools, we haven't gotten into, you know, trying to differentiate between like labile organic matters or mineral associated organic matter and things like that. We're just looking at total carbon.
And the other question that came in, Matt, during your presentation, do you work with governments and municipalities to provide quantification services for payments for ecosystem services?
Not currently, formally, but we've worked with a New York State Assembly member representing Columbia County in an effort to to create what was called a carbon farming pilot study. So my colleague Ben Dobson worked with that team to generate that that legislation, and that passed a couple of years ago in the budget, but kind of got away from us when the Soil and Water Conservation District sort of took over the management of it. So there's some politics there, but yeah, we're open to working with governments and municipalities, not only in New York but also in other states in the Northeast, to just share our research, our data, our learnings. We're an open source institution. Our ethos is, we're sharing our data, providing a public good through our research, and we want it to serve anyone who might benefit from it.
So that's all the questions I have right now from in the chat. I mean, really incredible discussions. We've been having a lot of these discussions at the with the Tompkins County group. The relationship between national markets and regional approaches. So I really appreciate you guys bringing some talking points to that. There's a good question that just came up. Does this apply only to farmland? What about retention ponds and set aside areas? Do you guys have anything?
For Nori, just farmland at this point.
For Hudson Carbon, the way we think about our research is in a little, more broad in context. We work with foresters, forest researchers, and also physical oceanographers and organizations that are sort of implementing ocean farming and things like that. And, we're interested in really connecting landscapes and management, different landscape management approaches, different ecosystems within this, carbon exchange that we're building. So forestry, blue carbon, green carbon, soil carbon, all of that. And, mostly to, within the context of a farm, a lot of farms in the Northeast have, a good bit of forested acres that, they might, feel pressure to open up to sort of meet the demands of the market, to meet scale, to stay in the black. So the idea of being able to monetize that existing ecosystem, which doesn't have a lot of precedent within existing markets, but I think it's important that existing ecosystems that provide carbon sinks are really on the front line of the work we need to do something about runaway climate change. So it's important to assess the right level of value to not only the existing sinks but also protecting them.
I got a question come in the chat here. How are y'all folks thinking about the question of compensating farms that have already transitioned to systems and practices that sequester carbon / steward water resources effectively?
I can start. So with the Nori pilot, we're offering up to 5 years of grandfathered NRT credits, or grandfathered years for NRT credits. And that kind of helps balance that buyers really want to have newly sequestered carbon, right? But we also want to meet farmers who've been doing things for more than just this year. So we do up to 5 years of NRT practices for a switch that's happened since 2010.
Matt, do you have any comments on that topic?
Yeah, no, I think what Nori's doing there is great, and of course Nori's operating on a more practical level at this point because they're operational. But just on a high level, yeah, I think it's the same concept, that would go to preserving adjacent ecosystems, which is that farmers have built this sort of natural capital that is soil carbon and biodiversity ecosystems. It's important to preserve it and not only, and to incentivize the continued preservation and building of those assets. So while certain definitions of additionality would discount that natural capital, those assets from being traded in a marketplace, I think it's important to sort of rethink how additionality is defined, and that we're dedicated to trying to figure that out and crack that nut, and help support practitioners who have been doing this for a long time, who deserve to be recognized financially for it.
Looks like we got a few NRT questions coming in. Do NRTs go to the landowner or the farmer leasing the land?
They go to the person who signed the contract. So typically what we've seen so far in the farmers we're working with is that we need an assignment of authority from the landowner to make the farmer typically the primary contact. And that's just saying they're where it's enrolled in Nori. We give permission to the farmer to enroll the project because the farmer is the one doing the work of the incredible work of trying to transition to these practices. So to date, it's gone to the farmer.
Do NRT? Okay.
Oh, just technically to the one who is the primary contact of the project.
Next question: do NRTs expire?
They do not at this point. So far we're in a fairly balanced. They get in, they get sold within a reasonable amount of time. But if you want to hold our NRTs, so this is forward thinking. It's not how we operate right now, but when we are tokens, you can hold on to them for however amount of time that you want.
So I have a question. If folks want to get involved with either of y'all's organizations, is Nori currently taking farmers? If farmers are interested in New York State, what should they do? If who might be on this webinar are interested, how can they get involved with Nori?
Right now, so because we're a very small team, we want to serve the people well who are serving. We're not taking new farmers directly at this time. However, we have a list of farmers that we're trying to train people up to help serve appropriately. So you can email at hello@nori.com, and we'll get you on that list as well. More information as you ask.
And Matt, I know y'all's works down the Hudson Valley, but you mentioned a few, advocacy bills and stuff that y'all are working on. Is there some way that, folks up here are interested could work with y'all?
Yeah, absolutely. We're open to exploring any path of collaboration, anywhere from, on-farm research. We're in a pretty big expansion year here where we're expanding our work within Columbia County. We're taking on projects in other parts of the US and internationally. So yeah, we're always looking to, expand our research into key regions, within the Northeast and abroad. So yeah, in any way, shape, or form, interested in at least exploring. So yeah, please reach out with any questions.
Appreciate that. Definitely going to be reaching out with our Tompkins County group to y'all. So I have another question that just came in. Have you started working on pollination as a compensatable ecosystem service? That might go to Matt more.
Exploring. Yeah, we've been exploring ways in which to quantify that within the farms that we're currently conducting research. And so, our approach would be like do very in-depth detailed inventories of pollinators and how that changes over time as a farm system transitions. But then, looking at ways to then do that on a more cost-effective level is kind of the balance that needs to be struck when taking in-depth research and using it to sort of then inform verification over time. So exploring it, the carbon piece is the most developed of the ecosystem service, within existing markets, but it's super important to get into the other the areas of co-benefits and develop the research and the monitoring methodologies to quantify them and create value. So yeah, definitely on our radar, and we're getting into that this coming season.
And one quick note for Nori. So Nori's goal is reversing climate change. So we'll only be a carbon marketplace. But within our contract, we have the ability for your land to be listed for in other ecosystem marketplaces for other things such as, water quality, pollination. But we hope that it just is one piece of the value of these sustainable practices.
And that's really interesting with the whole stacking benefits, on different markets. That's very interesting. So we just got a question here. Does a farmer take on any long-term liability when they sell carbon credits?
So for our marketplace, it's a 10-year contract. And the liability is that we're not prescribing practices in no way. We're saying you must continue this exact thing for the next 10 years, but we are saying you need to report the data so we can monitor those carbon fluxes. The liability at this point, like say you have 10 fields, one loses a little carbon, the next issuance would be less, right? We would just deduct it from your next issuance. And if there's issues this is always a tough conversation because the farming is so complex, right? There's so many variables involved, like landowners, leasing, getting taken over. But we have a force majeure clause that doesn't leave the farmer liable for things such as weather that causes carbon losses. And we have an insurance pool to make the buyer whole.
Love that. So it looks like we're almost wrapped up in questions, and I'd just like to really give thanks to Rebecca and Matt. Incredible presentations. I really wanted to. I've been kind of diving into this world on my own, and we kind of stepped into it with the town of Geneva. But I wanted to invite a larger group. Put a webinar out there to know what is going on currently. And I think you guys really highlighted, what is currently going on in this world. So I really appreciate, Seneca Lake Pure Waters for co-hosting this. I want to thank the Water Resources Council of Ontario County for funding the farmer payments and the speaker fees. And I just want everyone to know that the webinar has been recorded and will be available on the Seneca Lake Pure Waters Association YouTube page. Will be uploaded later today for your review and for sharing with those who are interested. You can see the YouTube page. You can see the YouTube link in the chat. And we'll be sharing this on the Town of Geneva website as well. So thank you so much for everyone who's attended. Remember, if you're a farmer in the Seneca Lake watershed, please fill out the survey so you can qualify for your $20 payments. You can see the link in the chat right now. So fill that out, get that over, and we'll get that to you. Thank you so much for everyone participating. All right, I think that wraps it all up. Thank you.
Thank you, everyone. Bye.
Thank you, Jacob.
Thanks so much, Matt. Really appreciate it.
It was a pleasure. Have a good one.